Good afternoon, students. Welcome back again. Students, am I audible to you? Can anyone confirm? Okay, thank you. So right now, 13 members joined. Let all to join. Then we will start. After a minute, we will start. Yes, students. So welcome you all. Let's begin for this session. So student, for the unit number one, okay, we have a three experiment related to IoT lab, that is Internet of Things. And here you have to first have the hardware with you. Okay, for the hardware, the main IoT platform is the ESP32. With the ESP32, the devices will be interconnected. Okay, and these will be used for some application. As second experiment is used for the weather monitoring. Third experiment is used for the smart home automation. Okay. So for the second experiment, we have this theory part. What is a program? Okay, so line by line, I'm explaining to you. So basically, the ESP32 it is enabled with the help of ESP32 is Wi-Fi enabled. Okay, so for that we should have the Wi-Fi in our environment. Okay, Wi-Fi should be there. So that is why first we have to declare the header file or library, okay, to enable the Wi-Fi. Include Wi-Fi.h. Okay, it allow us to connect ESP32 with the network. Okay, so it is the compulsion for ESP32. Then second thing, we are defining the LED. Okay, so because we have to use the LED here as the interfacing device, we are interface LED with the ESP32, which is the hardware, and the pin number of this LED is the pin number 2. Okay, pin number 2 uh, of ESP32 is used to connect the LED. Okay, find the number for LED and by which it is connected. If afterwards you want to use another pin, so then in the program we have to change the pin number as well. Okay, why pin number is required to be mentioned? Because we are making a IoT device. Okay, we are making a program in Arduino. So in program we have to declare that on pin number 2. Okay, on pin number 2 some device is there, so for to that device we are giving some signal. Okay, because ESP32 have many pins, so out of these pins at pin number 2 some device is connected, and to that device we are giving the signal, we are giving the message. So that is why pin number is required to be declared. Okay, because at pin number 2 you can connect the LED, at maybe pin number 8 you are connecting the weather monitoring sensor, at pin number 12 you are connecting the relay. Okay, so that is why it is compulsory to declare the pin number on which pin we are connecting. Okay, so that is why we are declaring here that we are using the LED and we are making the use of pin number 2. Next, students, as I told you, the ESP32 is Wi-Fi enabled. Okay, it need Wi-Fi. So that is why here Wi-Fi ID and password. These two things we have to declare as well. Okay, Wi-Fi ID and password. These two we have to declare. In our lab already Wi-Fi enabled is there. Okay, so when I will show you the program, so then you can see what is the ID, what is the password. Okay, every time, because ESP32 is Wi-Fi enabled, so also we have to declare the ID and password. Okay, because with that only we can connect to a Wi-Fi module. Yes, anyone have any doubt so far that we discussed? So next to this we have the word setup. Okay, what is the meaning of word setup? In every Arduino program, we have to write the statement word setup. Only within the word setup we can declare the logic. Okay, without word setup or without word loop, okay, the Arduino program will not run. So either word setup or word loop we have to write there. If we write the word setup, so initially the code that you put inside word setup will run only once. Okay, so word setup is always compulsory when we add on Arduino. Next logic we have the serial dot begin. Okay, serial. What is the meaning of serial? Serial means here we have the serial communication. Okay, here serial communication is used, and 9600 is the data rate. Okay, the serial communication data rate. So that data rate is accessible by the ESP32, and 9600 it's the bits per second. Okay, so that much speed the ESP32 have. So at a time it can run up to the 9600 bits per second. So that the speed it have in the this microcontroller, that is ESP32. Okay, so for serial communication, and a USB connection is there as I told you in the diagram. Okay, a USB port is present there on ESP32. That USB port is connected from ESP to the USB, sorry, CPU of the device. If you are using hardware in your laptop, so from your hardware, it will connect to the USB port of your laptop. Okay, but in the desktop, as in the lab we have the desktops, so hardware is connected with the CPU. From CPU, we are giving the changing the program, and that program is running on the ESP32 through the USB cable, and that cable is used to also give the that cable is also used to give the power. Okay, power supply to the this one, ESP32. Okay. So similar to this, for all the two programs, we have to make the program, okay, on the Arduino. Then we have to run the program on the ESP32. Okay. Based on that, the peripheral devices will be connected and they will work for some application. Then serial print is there, okay, to print the information. Okay, so prints data to the serial port, okay, in the form of ASCII code. Okay, so different modes are there. Then the important command is this one, pin mode. Okay, pin mode. What is the meaning of pin mode? Because as we are using the LED here, okay, how we are using LED in the form of output device. Okay, because we are making a program. By that program we are saying that up to which time it will be on, up to which time it will be off. Okay, it means we are using LED as a output. So that is why with the use of pin mode we are declaring the mode, either it is using for the input mode, output mode, or in out. In out means for both the purposes. Okay, the pin mode function is used to configure a specific pin to behave either as input or as an output. Okay, in out is also there. Okay, then another important two statements are these are the these are the important part. Okay, digital write. Okay, so first thing is, what is the meaning of digital write? Digital write means we are writing the digital data. Okay, the ESP32 is able to control both digital as well as analog inputs outputs. Okay, both availabilities are there, either we have digital signal or the analog signal. So here with the help of digital write we are declaring that we are using the digital data. Okay, for which we are using the digital data, we are using for LED. Okay, what is the LED? In the very beginning of the program we declare the name LED with pin number 2. Okay, and first we are declaring as the high. Okay, so initially we are declaring as the high. So what is the meaning of high? High means as it is, as I told you, it is the digital data. Okay, we are dealing with the digital data. Analog is also there, but we are doing the digital. So what is the meaning of high? High means it is the logic 1. Okay, or you can say on state. Okay, one term is the high. Okay, we are making it high, so it is also called the logic 1, or you can say on state. Okay, up to this time the LED will be on. LED will be on means it will give the light. And what is the meaning of low? Low means logic 0 or off. Okay, up to which time the LED will be off, or it is of logic 0. Okay, so both the logics we are declaring, either it is high state means the LED will be on, or it is low state means LED will be off. Okay, so as I told you in the last session, here are time units. Okay, so by default it is only 500. So what is the meaning of 500? It is millisecond, microsecond, nanosecond, or seconds only. Put in the chat box what is the meaning of this. Millisecond. Yes, Saksham, you are right. Okay, so by default the Arduino take the time unit as millisecond. Okay, so 500 millisecond becomes half second. Okay, so it is a very small time, so it will blink for half of second. Okay, it will on for half second, it will off for half second. So similarly, you can change the time. Okay, if I put it high 5000 and low 2000, it means for 5 seconds it will be on, and for 2 seconds it will be off. Okay, so it is the program that we have to use for this particular experiment. Okay, so it is the same explanation for pin mode as output and what is high low. So normally you can say it is logic 1 or logic 0. So 5 volt it is used for the logic 1, and 0 volt is used for the logic low 0. Okay, for high logic the LED will give light, and for low logic it will not give light, it will be off. Okay, so anyone have any doubt? Uh, so for that, students, you can also make circuit on Tinkercad if just for evaluation purpose you want to verify. Okay. Otherwise, in lab we have the hardware, so we will give you the remote access. So with that remote access, you can use the hardware. Anyone have any doubt? So right now I am trying to get the uh, remote access, so you will be able to see. So student, I am sharing my screen. Okay, I am sharing my screen. Then I will show you. Okay, which hardware is present in the lab and what we have to do. Okay. So students, I will give you the Zoom link. Okay. These are the Zoom links. For one group, I will give one Zoom link. Are you able to see my screen? Okay, so here you have the Zoom link. So I connected with one link, and it is a Zoom video. Okay, it is a Zoom video, and with this Zoom video, we have to control the things. Okay, right now here in this meeting, already these members are there. Okay, these members are there. They are doing some experimental work, maybe they are from other class. Okay, so wait 1 second, I will ask for video share from the lab instructor. So student, again, I will share my screen and show you the process. Okay, so these are the Zoom links, and so in the same way you have to open the link. Then with the VB, you will be directed to another link. Okay, and it is the hardware that is present in the lab. Okay, are you all able to see the hardware? Okay, so students, it is the hardware. Okay, so here this black body is the ESP32 that I told you, and this white cable is a USB cable. Okay, that is used to give the program to this device and also to give the power. It is a LED, okay, that we are controlling, and it is a weather monitoring sensor used in second experiment and a relay used in the third experiment. Okay, so when you connect to any, you can say, 1 second, when you connect to any meeting, okay, then you have to click on view options. When you click on view options, then option is request remote control. Okay, when you click on request this one, so one request is there, so click over there, then you will have this option, you can control. Okay, the request accepted from the lab. Okay, so then you will be able to control the laptop, sorry, desktop in the lab. Okay, now I will show you. So for example, if I'm opening one folder here, so it will be opened there. Okay, it is not in my desktop, you can see this screen is not my desktop, it is of the desktop that is present in the lab. Okay, I'm sitting in my cabin, but I am operating the system in the lab, and it is the hardware that is also present there. Okay, so what we have to do, as I told you, 1 second. So we have to open the program, and it is the software. It is already installed. That I told you. If you are not interested to install software in your laptop, no issue. Okay, because it is to be installed where hardware is present. Okay, so here I will open the program is already there. Okay, otherwise I will open the new program from file, open. Okay, go to the desktop. uh, One folder is there with the Arduino codes. It is first one. Okay, so I am opening the program. It is same program. I think someone made some changes. It is for 1 second. So if I make it for uh, on time 5000 means 5 second, and off time remains same 1 second. Okay, so from here you can see one arrow is there, so that is used to upload the program. So first it will compile the sketch, means check the program if it is right or not. If there is any error, so it will show the error. Now it is uploading the program. So it is just the evaluation. So in the next lab, I will be there in lab and I will see it, what to do for that. Maybe we have to connect the USB cable again. So student, it is the way. संदीप सर एक बार केबल निकाल के लगाना है उसकी यूएसबी. हाँ जी, 9 नंबर पे. Yes. Okay, thank you sir, thank you. Yes students, now you can see initially it was 1 second. Now you can see it is on for 5 seconds and off for 1 second. Okay, are you able to recognize it? Because here you can see we change the time as 5000, 5 seconds for on, and off second is only 1 second. Okay, and you can see here on time is 5 seconds. Now it is off for one only, but on for 5 seconds. Okay, so it is perfectly working. Is it clear? Some idea comes in your mind? Yes, students, reply here. Okay. Yes, everyone, is it clear how you have to perform? Okay. So is there any student who is working on laptop? Yes. Is there any student who is working on laptop? Yes, Shalu, are you attending class by laptop or by mobile only? Okay, Shalu, so I am sharing the Zoom link. So Shalu, you only click on this Zoom link, okay, and join the Zoom meeting. And I will show all the members how she is doing. Okay, now I am going to Zoom meeting. I will see either you joined or not. Okay, so in the same way, student, we have to perform other two experiment. In the next lab, I will give you remote access, everyone, group wise. Then you will perform the experiment. Shalu, have you opening the Zoom meeting? Yes, so two members joined, Varun Bansal and with Dell. Okay, I so student, one thing is that every time please when you log in with Zoom, so it will ask the name to display. So please enter your name and UID. Okay, so we can differentiate who is there. Okay, because we have to give the remote access as well. So if you are entering with Dell and other names, so we'll not be able to recognize you. Yes, Shalu, by which name you log in here, or who is with the name Dell? Parveen also joined. Okay, so it is the program on the remote PC. Okay, right now I have the remote access, and it is the output, it is the hardware that we have here in the present in the lab. Okay, here we have the hardware. Okay, that is working here, and the software is burning there. The program will run there. Dell. Okay, so you log in with the name Dell. So I am give up the remote control. Okay. Yes, Shalu. Now you click on the top view options. Okay. Then one option is the request remote control. That is the second option. Click over there. Yes, Shalu. Have you get the remote access? Okay. So student, now she have the remote access. Now Shalu, in the program, change on time to let's make it 7,000, 7 second, 7,000 on time, and make the off time also 7. Let it be 3 second. Just change the on and off time. Shalu, change the high and low time. 5000 change it to some other value. Make it 7000. 7000. Okay. And the low time, make it 3000. We don't have much time. Do fast. You remove the bracket sign. Yes. Now do the uploading. In the second row, the arrow is there, na? Forward arrow. Click there. It is for uploading. Now wait. Not this one. Second. After the tick mark. Yes. Yes. So it is compiling sketch, checking the program. Uploading is going on. Done uploading. So 1 second. Sandeep sir. Okay, sir. Now see student. Okay. Now off time is 2 seconds. It is also reflected here. Okay. Is it clear, everyone? Now on time is 7 seconds changed and off time is 2 seconds. That is also changed. Okay. So it is perfectly well and performed by one student. Okay. Now I am leaving this meeting because time is over. Stop sharing. Okay, is it fine? Are you able to get the things? So in the next lab, you all perform from your own. Okay, today also one student performed. Yes, Shalu, are you there? Okay, no issue. Yeah, okay. Okay, so thank you everyone. Thanks for joining. Now you can leave the session. Thank you.